Studies dating back nearly a century noted a striking finding. If you take young, healthy people, split them up into two groups, half on a fat-rich diet and half on a carb-rich diet, within just 2 days, this is what happens. The glucose intolerance skyrockets in the fat group. In response to the same sugar challenge, the group that had been shoveling in fat ended up with twice the blood sugar. As the amount of fat in the diet goes up, so does our blood sugar spikes. Why would eating fat lead to higher blood sugar levels? It would take scientists nearly 7 decades to unravel this mystery, but it would end up holding the key to our current understanding of the cause of type 2 diabetes. The reason athletes carb load before a race is to build up the fuel supply within their muscles. We break down the starch into glucose in our digestive tract. It circulates as blood glucose, also known as blood sugar, and is taken up by our muscles to be stored and burned for energy. Blood sugar, though, is like a vampire. It needs an invitation to come into our cells, and that invitation is insulin. Here's a muscle cell. Here's some blood sugar outside, waiting patiently to come in. Insulin is the key that unlocks the door to let sugar in our blood enter the muscle cell. When insulin attaches to the insulin receptor, it activates an enzyme, which activates another enzyme, which activates 2 more enzymes, which finally activates glucose transport, which acts as a gateway for glucose to enter the cell. So insulin is the key that unlocks the door into our muscle cells. What if there was no insulin, though? Well, blood sugar would be stuck out in the bloodstream, banging on the door to our muscles and not be able to get inside, and so with nowhere to go, sugar levels would rise and rise. That's what happens in type 1 diabetes. The cells in the pancreas that make insulin get destroyed, and without insulin, sugar in the blood can't get out of the blood into the muscles, and blood sugar rises. But there's a second way we could end up with high blood sugar. What if there's enough insulin, but the insulin doesn't work? The key is there, but something's gummed up the lock. This is called insulin resistance. Our muscle cells become resistant to the effect of insulin. What's gumming up the door locks in our muscle cells, preventing insulin from letting sugar in? Fat. What's called intramyocellular lipid, fat inside our muscle cells. Fat in the bloodstream can build up inside the muscle cell, creating toxic fatty breakdown products and free radicals that can block the signaling pathway process. So no matter how much insulin we have out in our blood, it's not able to open the glucose gates, and blood sugar levels build up in the blood. This mechanism by which fat induces insulin resistance wasn't known until fancy MRI techniques were developed to see what was happening inside people's muscles as fat was infused into their bloodstream. That's how we found out that elevation of fat levels in the blood causes insulin resistance by the inhibition of glucose transport into the muscles. And this can happen within 3 hours. One hit of fat can start causing insulin resistance, inhibiting glucose uptake after just 160 minutes. Same thing happens to teens. You infuse fat into their bloodstream, it builds up in their muscles and decreases their insulin sensitivity, showing that increased fat in the blood is an important contributor of insulin resistance. And then you can do the opposite experiment. Lower the level of fat in people's blood, and the insulin resistance comes right down. Clear the fat out of the blood, and you can clear the sugar out of the blood. So that explains this finding. On a high-fat, ketogenic diet, insulin doesn't work very well. Our bodies become insulin-resistant. But as the amount of fat in our diet gets lower and lower, insulin works better and better. This is a clear demonstration that the sugar tolerance of even healthy individuals can be impaired by administering a low-carb, high-fat diet, but we can decrease insulin resistance by decreasing fat intake.